In the annals of automotive engineering, few periods present a more intriguing dichotomy than the 1970s, particularly when examining the American luxury car. Designers and engineers of that era were driven by an almost singular pursuit: the ultimate isolation of the occupant from the harsh realities of the road. This quest manifested in what many still recall as an unparalleled ride quality, a sensation of floating over imperfections, a serene cocoon that absorbed every bump and undulation with effortless grace. It was, by all accounts, plushness personified, a truly opulent experience designed to convey status and comfort above all else. Yet, this very commitment to profound comfort birthed a paradox. The same suspension systems that delivered such impressive isolation simultaneously introduced some of the most notorious handling characteristics in automotive history. These large, softly sprung vehicles, while magnificent on smooth highways, often transformed into wallowing behemoths when confronted with a sharp corner or an emergency maneuver. They leaned excessively, communicated little to the driver, and demanded a driving style utterly alien to anything resembling agility. Why did a design philosophy so dedicated to passenger well-being ultimately create such profound dynamic compromises, transforming luxury into a liability when the road demanded more than just a straight line? The automotive landscape across North America throughout the 1970s presented a peculiar tableau. Fuel crises loomed, emissions regulations tightened, yet the underlying consumer expectation for grand, comfortable transportation remained unshaken. Such vehicles, particularly in their more aspirational forms, served as a statement of success, emphatically including a ride quality engineered to insulate occupants from the outside world. Prevailing wisdom dictated that a truly luxurious vehicle should glide, not merely drive. It functioned as a sanctuary, a quiet haven where the imperfections of asphalt and the jostle of everyday traffic simply ceased to exist. This deep-seated demand translated directly into engineering directives. Design briefs prioritized maximal occupant comfort above almost all other dynamic considerations. Suspension tuning became an exercise in achieving the softest possible spring rates, pairing them with generous wheel travel and highly compliant bushings. The aim was to create a detached, almost ethereal driving experience, where road harshness was meticulously filtered out. Steering systems were often deliberately overboosted, requiring minimal effort and offering little in the way of tactile feedback. Engineers sought to remove any hint of mechanical intrusion, fostering an illusion of effortless propulsion. At the time, this seemed like a brilliant idea, a logical extension of what the market was clearly asking for. The focus was singularly on the passenger's serene journey, irrespective of how the vehicle behaved when asked to perform anything beyond a straight-line cruise. Such methodology, while satisfying one set of desires, inevitably began to shape a very particular and ultimately problematic dynamic character for an entire generation of vehicles. The mandate for ultimate ride comfort fundamentally reshaped these vehicles' underpinnings. To create that gliding sensation, technicians specified extremely low spring rates. Consequently, the body settled deeply, allowing considerable initial compliance over road irregularities. While excellent for bump absorption, this led to pronounced body roll, squat, and dive during dynamic maneuvers. Designers paired this strategy with a philosophy embracing generous suspension travel. They desired ample vertical movement for the wheels, allowing them to articulate over substantial bumps and dips without transmitting abrupt shocks. Wheels could descend and ascend through their full arc, dissipating energy gradually. Further enhancing isolation was the extensive use of compliant, oversized rubber bushings throughout the suspension linkages and subframes. These soft components acted as vibration dampers, meticulously filtering out high-frequency road noise and minor harshness before it could resonate through the car's structure. Every load transfer point was effectively cushioned. The final piece of this comfort puzzle was the tuning of hydraulic dampers. Rather than firm settings for immediate body control, these vehicles typically featured soft damping. This allowed the suspension to compress and rebound with minimal resistance, contributing to that floating sensation, often leading to gentle body oscillation. Many designs also carried significant unsprung weight, the mass of components like wheels and solid axles not supported by the springs. Paradoxically, this inertia, combined with ultra-soft springs and damping, could absorb certain road frequencies, yet made the suspension less responsive to rapid surface changes. Such an intricate interplay of components was all engineered towards a singular objective, an unparalleled, isolated journey. The pursuit of an utterly detached ride, while achieving its primary goal of isolation, inevitably introduced a profound dynamic compromise. Whenever these luxuriously soft machines performed anything beyond gentle, straight-line cruising, the fundamental laws of physics asserted themselves with undeniable force. Take a simple corner, for instance. The extremely low spring rates designed for bump absorption offered minimal resistance to lateral forces. The result was often dramatic body roll, where the entire vehicle leaned significantly outwards, feeling unsettlingly close to its limits. This wasn't merely visual. It fundamentally altered the tire contact patch, reducing inner wheel grip and making precise steering a constant battle against a wallowing chassis. In a similar vein, soft hydraulic damping, effective at smoothing imperfections, struggled to control the car's substantial mass during longitudinal weight transfers. Under braking, vehicle momentum caused pronounced nosedive. The front suspension compressed deeply, shifting the center of gravity forward, potentially reducing rear braking effectiveness. Conversely, during acceleration, the rear suspension would squat significantly, lifting the front end, leading to vague, disconnected steering as front tires lost optimal contact. Constant, exaggerated body motion created a pervasive sense of driver detachment. The steering wheel, often light and over-assisted, offered minimal feedback on the front wheel's activity. The brake pedal felt mushy, obscuring the precise point of maximum deceleration. Even throttle response, muted by delayed suspension reaction, contributed to piloting a large, comfortable boat, not a responsive automobile. The driver became a passenger, isolated from road harshness and crucial dynamic information, eroding confidence in anything but the most gentle maneuvers. When the unexpected occurred, these vehicles transitioned from serene cruisers to unsettling, unpredictable machines. Picture a sudden need to swerve around an unforeseen obstacle or an abrupt lane change initiated at highway speeds. The extremely compliant suspension setup, designed primarily to absorb gentle road undulations, proved utterly incapable of managing the rapid, violent shift in the vehicle's substantial mass. The car would lurch dramatically, its body lagging behind the initial steering input, then oscillating violently from side to side like a pendulous weight. Such delayed, exaggerated responses made precise, immediate control nearly impossible. During an urgent, evasive maneuver, drivers often experienced a terrifying sensation of the rear axle losing its grip, or conversely, a stubborn refusal of the front wheels to respond, leading to uncontrolled understeer. High-speed cornering, if misjudged even slightly, could provoke a dramatic lean and a profound loss of composure, with tires audibly protesting as their contact patches distorted under the immense body roll. The soft damping, so effective at isolating road imperfections, now struggled to arrest these extreme motions, allowing the car to wallow uncontrollably through the crisis. The safety implications were undeniably clear and deeply concerning. What began as a design philosophy centered on passenger comfort culminated in vehicles that could become genuinely dangerous when confronted with dynamic emergencies. Drivers, once lulled into a sense of effortless travel, quickly developed a deep apprehension about pushing these cars even slightly beyond their intended leisurely pace. This realization wasn't just about ride quality anymore. It was about fundamental safety and the very definition of vehicle control. The stark reality was that isolation from road harshness could also mean isolation from the critical feedback needed to maintain command in a crisis. Unsettling revelations regarding dynamic instability sparked a fundamental schism within the automotive world. As the understanding of suspension dynamics evolved beyond mere comfort, Different manufacturers began to interpret and address these emerging concerns in markedly divergent ways. On one side, many domestic brands, particularly those catering to the luxury segment, initially doubled down on their long held philosophy. They perceived the soft is luxury mantra as sacrosanct, a core tenet of their brand identity, and a direct response to perceived consumer demand for effortless, isolated travel. Their engineers often sought to mitigate the most egregious handling deficiencies through subtle modifications, but without fundamentally altering the plush, compliant character that defined their vehicles. Conversely, a different philosophy was quietly gaining traction, championed predominantly by European imports. Brands like BMW, Mercedes-Benz, and even some British marques had for decades prioritized a more holistic approach to vehicle dynamics. They advocated for a balanced suspension setup that provided both commendable ride quality and a higher degree of road holding, steering precision, and driver feedback. Such engineering meant firmer springs, more controlled damping, and sophisticated independent suspension designs that communicated critical information from the road surface without punishing occupants. What happened next changed the industry. As automotive journalism, once heavily focused on subjective ride impressions, began to shift its emphasis. Publications and critics increasingly highlighted objective metrics like cornering grip, slalom times, and braking stability, educating the public on the tangible benefits of a well-sorted chassis. This growing appreciation for handling and control started to erode the unchallenged supremacy of ride comfort, fostering a new, more discerning consumer base. An evolving consumer palette coupled with the undeniable performance advantages demonstrated by overseas competitors initiated a profound reevaluation within domestic manufacturing. The era of the overtly plush, almost disconnected ride, characteristic of many late 1970s American luxury cars, was slowly giving way to a more nuanced understanding of vehicle dynamics. Engineers began a systematic reassessment of their chassis setups. A pivotal change involved the widespread adoption of stiffer anti-roll bars, often termed sway bars. These crucial components, connecting opposing wheels, dramatically curtailed body roll during cornering, fostering a more planted feel. Simultaneously, gas-charged shock absorbers proved transformative, maintaining consistent damping and offering superior control over suspension oscillations without sacrificing initial ride compliance. In parallel, suspension systems advanced significantly. Simple live axles offered limited geometric control, thus, the embrace of multi-link designs, particularly at the rear, allowed engineers to precisely manage wheel alignment, camber, and toe angles throughout the suspension's travel. This yielded enhanced grip and predictability, especially during dynamic maneuvers. These engineering strides were not made in isolation. The relentless pursuit of dynamic excellence by European marques, whose vehicles consistently outperformed American counterparts in road tests, served as an undeniable catalyst. Benchmarks from vehicles like the BMW 5 Series or Mercedes-Benz E-Class became tangible targets, compelling a paradigm shift from prioritizing isolation to a balanced equation of comfort and control. Such efforts triggered a palpable transformation in how American cars felt on the road, marking a definitive pivot towards a firmer, more engaging driving experience, laying the groundwork for the performance sedans of the 1990s. Insights gleaned from this era of suspension experimentation, particularly the shift away from extreme isolation, profoundly shaped the automotive landscape we navigate today. What began as a reactive adjustment to market demands and competitive pressures has since evolved into a core engineering philosophy, the pursuit of a precise dynamic equilibrium between ride comfort and handling prowess. Modern vehicle architectures are designed from the ground up to achieve this delicate duality, ensuring occupants are shielded from road imperfections while simultaneously providing the driver with predictable communicative control. Contemporary suspension systems stand as paragons of this refined thinking. While passive components like springs, dampers, and anti-roll bars remain fundamental, their tuning has become incredibly sophisticated. The true revolution, however, lies in intelligent technologies, active suspensions, and adaptive dampers. These systems utilize an array of sensors to monitor road conditions, vehicle speed, steering input, and even driver behavior in real time. Adaptive dampers, for instance, can or instantly adjust their valving to stiffen or soften, providing a plush ride over a rough patch one moment and firming up for spirited cornering the next. Active systems take this further, employing hydraulic or electromagnetic actuators to actively push or pull on the suspension, counteracting body roll and pitch with astonishing speed and precision. This technological leap means that a single vehicle can now offer the serene cruising comfort once associated with a traditional luxury barge, yet transform into a surprisingly agile machine when the road turns winding. It serves as a testament to decades of iterative refinement, where the extremes of the past forged the sophisticated balance of the present. Reflecting on this complex evolution, it becomes clear that the essence of vehicle dynamics engineering has always been and remains a study in elegant compromise. Every pivot point, every spring rate, every damping curve represents a deliberate trade-off, a careful weighing of conflicting desires. The 1970s, with its dramatic swings from plush isolation to attempts at European-style firmness, stands as a particularly vivid chapter in this ongoing narrative, illustrating precisely where those compromises can lead when the pendulum swings too far in any single direction. Achieving the ideal balance between serene ride quality and responsive, confidence-inspiring handling is not a destination, but a perpetual journey. Such an iterative process ensures that each generation of engineers builds upon the successes and lessons, often hard-won, of their predecessors. Moving from early experimental setups to today's adaptive predictive systems, the core challenge endures: how to connect a vehicle to the road in a way that is both comfortable for its occupants and engaging for its driver. This quest for dynamic perfection is a story woven into the very fabric of automotive history, continuously unfolding with every new chassis design and every technological leap.